All right, this is a continuation of the last video. We are graphing rational functions, and we are graphing them by using these 7 steps. So the first thing we want to do is find the domain. And when I find the domain, this always needs to be before you simplify. So here, this is already in factored form. So before I simplify anything, I'm going to find my domain by setting the bottom x plus 5 and saying that it cannot equal 0. Your first one right here is that x cannot equal 0. And from here, we get x plus 5 cannot equal 0. So x cannot equal -5. So my domain is a set of all x such that x cannot equal 0 or -5. That is the only thing we absolutely need before we simplify. Now I'm going to go ahead and take this and I can cancel out some x's. And this reduced in a simplified version is 1 over x plus 5. So now when I go to step 2 and I find vertical asymptotes, this is always your simplified rational function. What I have in the denominator is only x plus 5 equals 0. So therefore, x equals -5 is my vertical asymptote. So we'll come along here to x equals -5. And now find any holes. This is what canceled. And what canceled in this was my x. So I have a hole at x equals 0. So if I want to find that ordered pair, I need to plug in 0. If I plug in 0 into this one, I'm going to get it over 0, right? That's what we set the denominator equal to. So 0 is going to cancel everything out. So when I plug this in, I have to use my simplified version. And so when I plug that in, I get 1 over 0 plus 5. So I get 1/5. So I have a hole at x equals 0, and at x equals 0, we get the ordered pair 0 and 1/5. So on my graph, I'm going to put that. And it's kind of hard to do, especially since that's over the y-axis here. So I'm just going to make a note. That's a hole. Okay, it's not a solid circle. That is a open hold point. Fourth thing we need to do is find horizontal or oblique asymptotes. It doesn't matter which version you look at here. Here, my n is 0, my m is 1. So my numerator is less than the degree in my denominator. You get the same thing here. You have an n of 1 and you have an m of 2 because x times x gives you x squared. So either way, you have something less than. And so when that happens, your horizontal asymptote is just simply at y equals 0. So this is case number 2. And case number 2 tells me y equals 0. Okay. All right, there's my horizontal asymptote. Again, I had to put it below that just so it will show up, but it is the x-axis. Step 5 is to find your x-intercepts. You find your x-intercepts by letting the numerator equal 0. It doesn't matter which one you pick. Yes, it does, actually, doesn't it? When you do this, this has to be your simplified rational function as well. So I'm going to take this numerator of 1 and set it equal to 0. Well, this doesn't make sense. 1 does not equal 0. And so on our first problem that we did, when this doesn't make sense, this means that we have no x-intercepts. And I didn't explain this on that first one, but I feel like this should make sense. If you have a horizontal asymptote right here on your x-axis, that means everything's going to approach y is 0, but it's never actually going to touch it. So if it's never going to touch it, then you're never going to have a point along this x-axis here. And so we've got no x-intercepts. Okay, because that horizontal asymptote is the x-axis, you're not going to have any x-intercepts. 6, we need to find our y-intercepts, and we're going to do that by letting by x equals 0 and solve for y. I'm going to take my simplified version again. Okay, and you have to. So let's just make a note of that. Put a 0 in for your x. So we're going to have 1 over 0 plus 5. It's going to be 1/5. So I have 0 over 5. That's what we have right here. That's where my whole is. So we actually have no y-intercepts because where that is a whole. Okay, and now we need the calculator. We have our vertical asymptote, we have our horizontal asymptote, and we know where our whole is. So then put this in to fill in the gaps. I'm going to put in my simplified version. So 1 divided by parentheses x plus 5 and graph it. There is our vertical asymptote right there. And you can see it's approaching y equals 0 from both ends there. So we're going to go through that hole. And then it will come this way like so. If you want this to be more accurate, go second table and you can plot some ordered pairs. Okay, 2 more examples of graphing. Okay, let's factor this. We don't quite have enough room to factor this again. We do a little bit. Okay, let's factor this up here. So this one's a hard trinomial. You know it's a hard trinomial because your a is not 1. But my a times c is 4. My b term is -5. What adds up to b and multiplies to ac? You get -4 and -1. -4 times -1 multiplies to a +4, but when I add, I get to -5. Because this is hard, we need to rewrite that middle term. So this will become 2x squared minus 4x minus x plus 2. Then we'll factor by grouping. In this group, we get 2x, which leaves me with x minus 2. In this group, we want this to be positive. So to be positive, we're going to take out a negative. And I can't divide anything else out besides -1, which will leave me with an x minus 2. So this factors to become 2x minus 1, x minus 2. And then the bottom is a difference of squares. So that's x plus 2 and x minus 2. These cancel. And I am left with 2x minus 1 over x plus 2. Number 1, we need to find the domain. And we find the domain by looking at the rational function before it is simplified, before things cancel. So I'm looking at this right here. It's got to be in factored form, but it's before things cancel. So my denominator is I'm setting the bottom equal to 0. Technically, to not equal 0. And so here we get our domain that x cannot equal plus or minus 2. The second thing we do is find vertical asymptotes, and we do that by using our simplified version. Really, from here on out, we use nothing but simplified versions. So I'm going to take my simplified version, and I'll set this equal to 0, and this is going to give me a vertical asymptote of x equals -2. So that x equals -2. There's my vertical asymptote. 3, we need to find our holes. And we find our holes by figuring out what has canceled. Well, over here, we had an x minus 2 cancel, which means I'm going to have a hole at x equals 2. Now, I can find out where my hole is, what the ordered pair is, by plugging that in to my simplified version. If I plug that into my unsimplified version, it's going to get 0 in the bottom. That doesn't help me. So I have to use this one. So I have 2 times 2 minus 1 over 2 plus 2. I'm going to get 3 over 4. So that ordered pair is 2, 3 over 4. So I will put in my hole, 2 and 3 over 4. So that is a hole, not a dot. Number 4, we need to find any horizontal or oblique asymptotes. So it doesn't matter which version you look at. Here your n is 2, your m is 2. Over here your m is 1, your m is 1. So either way, your numerator is equal to the degree in the denominator. And when that happens, our horizontal asymptote is the ratio of our leading coefficients. Either one, I have a ratio of 2 in the top over 1. So my y-intercept, or my horizontal asymptote, is y equals 2. Step 5, find the x-intercept, and you do that by letting the numerator, or setting the numerator equal to 0 and solving. So I'm going to take this one here. I've got 2x minus 1 equals 0. Add your 1 over and divide by 2. And x equals 1/2. So that ordered pair, because again, if you leave this as this way, how do I know that's not a vertical asymptote? Your ordered pair is 1/2, 0. Which is about right here. Six, your y-intercept by letting x equal 0 and solving for y. So plug in a 0 for both of those. So we have 2 times 0 minus 1 over 0 plus 2. Cancel, cancel. We get negative 1/2. So this is 0, negative 1/2 for my y-intercept. So about right there. So I can kind of see that this one is going to be like so. If I had to guess, this one's going to be right up here, but let's just check. So parentheses, 2x minus 1, closure parentheses, open them, x plus 2. I know this is standard, so I'm just going to hit graph. And there it is. And you can go to second table to get some more ordered pairs to make it a little bit more accurate. You can see though, there's our vertical asymptote right there. And you can see as you go further here, this is getting closer and closer to 2 of that y equals 2. But it will never get there. And then our last example and last portion of this lesson is this right here. You have x to the 4th plus 4 over x squared. Because this is a plus 4, that means that this doesn't factor. If that was x 4th minus 4, then we could factor that. But the plus means we can't. So find the domain. You find the domain by setting the denominator to not equal 0. To get x squared by itself, you take the square root of both sides. And so this tells me that x cannot equal 0. We'll do the same thing to find our y-intercept, or sorry, our vertical asymptotes. And so this tells me I have a vertical asymptote at 0. Okay, again, I had to kind of put this on the right, but that's only to make it show up. It is the y-axis. Because nothing cancels, we have no holes. We need to find our horizontal or oblique asymptotes. Here, my n is 4, my m is 2. So this is case 3. Because my numerator is more than 2 than the degree of my denominator, we have no horizontal or oblique asymptotes. We need to find our x-intercepts. We do that by setting the numerator equal to 0. So I've got x to the 4th plus 4 equals 0. Subtract our 4 over to get x equals negative 4. I don't know if we've ever done this in this class yet, but the opposite of the 4th power is taking the 4th root. And when I put that in my calculator, we get a non-real answer. Because this is an even root, You cannot take a negative under that radical. So therefore we have no x-intercepts. Okay, so it's not going to touch this right here. 6, I need to let x equal 0 and solve for y. So when I put in 0 here, we get 0 to the 4th plus 4 divided by 0 squared. Cancel, cancel. I'm left with 4 divided by 0. This is not allowed. This is undefined. So that means I also have no y-intercepts. So this is all I got before I go into my number 7 using my calculator. I have no x-intercepts, no y-intercepts, no horizontal asymptotes, no holes in this graph. The only thing I have is my vertical asymptote of x equals 0. So let's put this in our calculator. Parentheses x to the 4th plus 4 divided by x squared. And there is my graph. So this time I am actually going to use the table. Let's kind of make this somewhat more accurate. Okay, -3 is about 10. -2 is 5. -1 is 5. 0 is an error. That's my asymptote there. So if I had to guess, this is going to come down just a little bit and loop back like so. And then this side should mirror itself. 1, 5, 2, 5, and 3, and almost 10. So it goes a little bit lower, circles back, something like that. All right, that is the end of graphing. Next lesson, we are going to be using this to go over rational inequalities. So you need to be able to do lessons 1 and 2 before we can do not rational functions or equations, but rational inequalities.